This is lesson number 4 of Computer Science 20S, and lesson number 4 really has no computer part to it. There are no scratch assignments with it. This is strictly sort of a thinking type of lesson. Lesson number 4 has to do with algorithms, and an algorithm is really just a set of instructions that solve a problem. And there's a couple examples here on your handout and on the slide. Buying items in a shop, choosing a package of crisps and a drink from the shelf, go to the checkout, wait in queue. These are just simply instructions, okay? Baking a cake. Once again, this is a set of instructions here. Mix milk and vinegar, melt the chocolate, seed the flour, cocoa, and soda into a bowl, and so on, okay? You can see the instructions are quite lengthy, okay? These are both sort of everyday algorithms, okay? A set of instructions. Now, here's sort of a definition. A good algorithm leads to completion. In other words, it does what it's supposed to. It's accurate, and it's unambiguous. Okay, so it's accurate. It does exactly what it has to, and it's very specific. It's not vague. It has the appropriate level of detail. It's not too detailed, but just enough. And we'll get into that in the near future as well. Humans and computers have different needs for different levels of detail. It has well-ordered instructions. The order of them is very important. You certainly can't beat until smooth over here in the cake until you've done all the steps ahead of time, kind of thing, okay? And it also covers all possible outcomes with practical solutions. And this is very important when it comes to computers. You have to cover all possible situations with practical solutions. You have to always assume that the person using the program doesn't know what they're doing and may be making some mistakes. Okay, so once again, here's the good algorithm criteria. Okay. Now, humans versus computer algorithms. With human algorithms, we can rely on our intuition, our own initiative, our prior knowledge, our independent decision making, and our learning from experience. Okay. Humans can use common sense, is what it boils down to. Computers do not have these things. They do not have common sense, and therefore we must take this into account when we write the algorithm for a computer program. You must tell the computer exactly what to do, and it must be in exactly the right order. Now, there are some instances where order may or may not matter, and a good programmer knows when the order does matter and when it doesn't. So here's a little practice assignment and this is a classic question, to write an algorithm to solve the farmer's problem. The farmer has 3 items. He's got a dog down here, he's got a goat up here, and he's got a cabbage to take across the river. And he only has a boat. He can only take 2 objects at once. In other words, the farmer and 1 other item. The boat is no bigger than that, okay? So write an algorithm to tell the farmer how to get the 3 items across the river. And there's a couple of restrictions here. If the dog and the goat are left together, the dog will eat the goat. Look at him, he's a mean-looking dog. And if the goat and the cabbage are left together, the goat will eat the cabbage. So the only 2 things that you can leave together are the dog and the cabbage. You can only leave these 2 together. You cannot leave these 2. You cannot leave these 2 together. So take a minute or so and see if you can figure out what the steps are for that. Click pause. Okay, well, I hope you've made a good attempt at that. Here's the solution. Begin on side A, take the goat across to side B, return with the empty boat to side A, take the dog across the river. You have to return with the goat, pick up the cabbage, take it back to side B, return with the empty boat, and then take the goat over to side B, and then you're all done, okay? So just sort of a little puzzle there that maybe people have seen, puzzle books and whatnot, but it gets you thinking about the steps that you do things. You have to account for every single possibility. Okay, so just a quick little assignment here. I would like you to write out the pseudocode. Pseudocode is simply a way of discussing computer steps in sort of everyday English. So I'd like you to write out the assignment, the instructions, the algorithm, the pseudocode for making a peanut butter and jelly sandwich with an appropriate level of detail. All right, and that is your assignment for lesson 4.